circular motion. So alright, this is surgical medic on your screen, and we will be going into circular motion. Alright, this is the Brilliant Academy. Also, we simplify, topics in such a way you never forget again. So quickly, let's just go. Don't have to waste so much time. The goal is to, demystify circular motion in this video. So ensure you follow closely, because every seconds, every minute of this video is good. Alright, what is circular motion? Just as the name implies, circle plus motion. So the motion of a body, or an object, actually, the motion of a body or an object, in a circular path is what is referred to as what? Circular motion. Are you with me? So, like the motion of a body, or an object, along a circular path is what is referred to as what? Your circular, motion. And you have simple examples under it, where you have, a rotating fan, or professionally, you say the blade. How do I draw the blade now? Let me just draw it like this, then let me draw the second one like this, then how do I draw it now? Then this. Okay, wow, that's okay. So as you can see, like the blade of a rotating fan, that is like the rotating blade of the fan that is rotating along its axis. You can see that it should actually be what? Set into what? Motion. As you can see, like, so the motion of it rotating like this is what we refer to as what? Our circular motion. So if you want to reach out to me, feel free. This is my number here, 09038425407. Reach out to me as fast as possible. Okay, for tutorials, and you can check for the link in the description of this video. The link to the classrooms are there. Just join. It's free. Join. So okay, so we have a lot of examples. We have examples of rotating fan. You have the example of your M of E. Your M of E, that's the moon orbiting the sun. MEME, like the moon orbiting the earth. The moon orbiting the earth. So we have more examples, like your a car moving around the roundabout and a stone tied to a string. So now let's look at, I think that's the very first thing you need to understand, like, your part 1. Then your part 2 will now be the secrets. What's the secret behind this circular motion? Are you with me? The secrets behind this circular motion. So according to Newton's first law, that says all objects or body will continue to move in a state of rest or of uniform motion unless it is acted upon by an external force. So this thing, as it is, it will continue in a state of rest. Like, it will not move unless you, like, maybe you plug it into a DC, or you apply current to it. So, and the moment you apply current, it will continue in a state of what? Of rest. Now, an object also continue moving in its original direction unless a force act on it. So that's what's it called? This is our guy, Newton. Yeah, that's my guy. He's actually my guy. So that was what Newton is actually trying to communicate to us. Now let's go. So now let's see if you swing a stone attached to a string. So alright, let's check. This stone, let's use this one as our stone. So already stone. So now you now attach this to a string. How let's say this is our string. Are you with me? Now maybe you now hold it. There's now maybe this guy here come down. Maybe he come down here. So you now hold the string. He's now wheeling it, like he's swinging it, swinging it. Are you with me? He's now swinging it. He's swinging it. He's swinging it. He's swinging it. He's swinging it. So as this guy here is actually swinging it, you will see that this one will continue in a circular path. Now you will not be thinking that you will not be thinking that, okay, what can happen to this stone? Oh, what will happen? Oh, so try to think for a moment that, okay, what will happen? Like, what will happen to this stone when as this guy is actually swinging? I'll wait for 1 minute for you to think. It's very, very simple. So the thing is, the stone want to move outward, like it want to like fly away, but it cannot fly away. Why? Because of this string that this guy here have already like tied to the stone. So it will not allow the stone to what? Fly away. So then this string will keep it, you know, at the like will pull it inward. It will pull the stone inward, then it cannot fly away. Then this one will continue in its circular path like that. It will continue in its circular path. It will not be able to fly away. Then the string is like bringing, how would I call it now? Like it will be like like inward, like an inward pull. So and this inward pull is what changes its direction continuously and keep it moving in a circle. Are you with me? So alright, that's that. So if they should ask you now which kind of force, it will be an inward force. So this string is causing an inward force. Will the stone fly away? The stone will not fly away. The stone will what? Because of that inward force, will be pulled inward. Pull inward. So please take note. These are things you should take note of. The stone will not fly away. So that is the concept. That is the secret behind a stone that is wheeled, or a stone that is being swinged. Are you with me? Alright. Now, this beautifully bring us to our what? Our centripetal. Now, what is now centripetal force? This inward force. This inward force that is bringing that is causing, you know, I told you that when this guy is actually swinging, this string will be pulling this object inwards. So, and you know that it's a force. So this is the force. This is the name of that force. This is the name of that what? Inward force. So that inward force that is causing an object or body is keeping an object or body moving in a circular path is called centripetal force, and the formula is given as what? F is equals to mv square over r. Are you with me? Mv square over r, and your mv square over r, your m here is given as what? Your mass in what? Kilogram. Your v here is given as what? Your velocity in what? Meter per second. Your r there is given as your radius in what? Meter. Then your force, which is measured in what? Your Newton. So everything will carry what? Newton. Is this thing easy or not? It's easy. So the centripetal force, like the force that is causing the object to continue in a circular path, that force that is acting, causing it to like keep moving. Then the inward it's an inward force. You should not forget it's an inward force. So ensure you take notes of all these things. Are you with me? So alright. Yeah, that's centripetal force. And we have the examples. Centripetal force directed towards, you know, the center of a circle. And example of centripetal force would be like your tension, your friction between your tire and the road. Tension, friction between tire and the road, and your gravitational force. Exactly, gravitational force between planets. So that's, you know, your examples of centripetal force. So now we have more examples, examples of a car that is driving roundabout, that is rounding about a circle, a stringed instrument that is wheeled. So like all of that. That's how we have one of the string, the string experiments. Yeah, the string was experiment. So all right, okay. There are some formulas you have to even master. There are some formulas you have to master. There are formulas you have to know, like your formula for your angular velocity, formula for your angular speed. Yes, your centripetal acceleration. Acceleration is given as what? Acceleration is given as your v square over r. So you should know your v is given as your angular velocity r. You should know all these things. Which is one can be substituted into wr again, and then you square. So very simple. Very simple. Are you with me? Okay. So let's check. Let's try to check. Now let's look into some terminologies. Here we look at something like period, frequency, angular speed, angular displacement. Alright, so yeah, angular. Let's start with angular speed. Angular speed under your under your circular motion. So you don't need to panic. When we get to simple harmonic motion, we'll go deeply. We'll go deep into all these things. Yeah. So angular speed is just telling you about how fast the thing is moving. Maybe you have a rotating fan now that is rotating. Of course, your centripetal force is the one that is actually causing this thing to rotate. Abi, okay. Now, so how fast is the fan rotating per second? That's your angular speed. Are you with me? And it is given as the ratio of your angular. Very simple, very simple. As you can see it here, as simple as it is. You don't need to panic. Here is what your frequency, your pipe is given as 3.142. Then something that is given like W here is now your speed. Actually, we have our angular speed and velocity. Are you with me? So alright, angular speed, is kind of the same, but what's differentiating this and this? From the video I made on scalar and vector quantity, I actually explained, the differences between our speed and velocity. Because velocity now, sure you get, would be a vector quantity because it's having both magnitude and direction. But speed is a scalar quantity. Sure you get. So now, thing is now that this one, speed is the rate of change of your distance with time. This one is the rate of change of displacement with time. And this one is measured in a specified direction. This one is not measured in a specified direction. That's why if you have this one now under circular motion, you can have as maybe they give you 20 rads per second. 20 there is your magnitude, which is your value. Why? The direction is just telling you that something like the distance. So alright, now let's move. Angular speed. Now if you now want to define angular speed, you tell them that okay, angular speed is the rate of change of the angular angular distance per time. Angular distance per time. But for angular velocity will not be the angular displacement with time in a specified direction. So can you guys now see how simple the thing is? Can you guys now see the differences between angular speed and velocity now? So we can now compare our given corresponding value. Maybe from your v equals to s over t, and all those blah blah blah. I don't think you guys need that. So just know your basic formulas. Know your formula v, which is equals to your wr, your angular velocity R. Sure you get. So alright, now let's move. So I think that's that about that. When we get to simple harmonic motion, we'll go deep. So let's just take some few examples. Few examples. Let's say a mass. It will pop up on your screen actually. A mass of 10 kilogram. So you have a mass of 10 kilogram. Do that. Moving in a circular path of radius 2 meter. So your R is what 2 meter. Then now says that with uniform speed of 50 meter per second, uniform speed 50 meter per second, that's your V. Alright, that's your V. Find the centripetal acceleration and the corresponding centripetal force. So now how will you look for your centripetal acceleration? What's the formula for centripetal acceleration? I told you the formula for centripetal acceleration is what V square over R, and this centripetal acceleration is a characteristic of circular motion. So you have 3 characteristics of that circular motion that you must master, which is your variable or changing velocity, your centripetal force, and then your acceleration, your centripetal acceleration. You have to take note of all these things. So now, how do you calculate for your centripetal acceleration? It's given as your V square over R. And what is your V? 50 square. What is your R? 2. Are you with me? So your 50 square divided by R, do it. Now, they said I should do for your centripetal force also. Then you use this formula for it. What's the formula for your centripetal force? Very simple. That's your F, which is equals to mv square over R. And as you can see, this is your M here, you put it here. This is your R, you put it here. This is your V, you put it here. So yeah, that's that. So maybe in the next lecture video we'll go into our remix. Here we'll solve multiple questions, maybe up to 50. Yeah. So if you want, comment fire in that comment section. Drop fire emojis in that comment section. I'll know that okay, you guys are actually ready for it. Alright, so that's that. You can send your answers, press the calculator and send your answers in the comment section. Also, alright. So yeah. The surgical medic, and physics is not about memorizing formulas. It's not about memorizing formulas at all. It's about understanding one simple idea. An object wants to move straight, but an inward force continuously changes its direction. That's the secret behind every orbit, every spinning wheel, every turning vehicle, anything in a circular path. So if this lesson helped you, maybe master circular motion or in any way or anything, just comment below. Just comment fire. Just fire emoji. Fire emoji is okay. This is surgical magic from Brainiac Academy, and I'm rooting for you always. Alright.